When we talk about the network level, we're back at that layer 4 again. So we're talking about UDP, TCP, everything that happens beneath the application protocol itself. Now let me give you a very basic overview of what I mean by network level defenses. Let's say we have legitimate traffic being routed through to a website. That traffic is going to go through network infrastructure, so firewalls for example. And ultimately, because it's legitimate, it's going to be routed through to the origin website, so the site actually running the application. When we bring in our malicious traffic and those requests hit the network infrastructure, we want to see them blocked. Now obviously this is very high level, but the premise I'm trying to communicate here is that network level defenses will block malicious traffic at that network infrastructure. They're trying to keep it away from the website behind it. And what you might actually find is that there are multiple points upstream of the website which can defend against that malicious traffic. Let me give you an example of how that may happen. Hardware appliances like Coriros are a perfect example. So here we're talking about a device that sits upstream of the website, routes every request through it, and it has the ability to identify malicious traffic and take appropriate actions. Now what I really like about the way Coriro represents their equipment is this diagram, and it's a really good illustration of where this defense sits in the stack. That network appliance is literally the first line of defense, and it knows specifically what to look for in terms of malicious traffic. This doesn't change all the other things that sit behind it. You still have things like firewalls, but many firewalls are not designed to defend against a denial of service attack. Now not only might you have a traditional firewall sitting behind an appliance like this DOS device, you may well then have other network appliances sitting behind that. So for example, a web application firewall, which is going to operate up at that layer 7, but it's going to be looking at HTTP traffic rather than looking at the lower level protocol of TCP, which the Coriro device is looking at. So this is one good example of what I meant when I said multifaceted earlier on. Different layers of defense at different points in the network stack, defending against different classes of attack. But what does a network appliance sitting out there facing the public actually do? Let's have a look at some examples. So we're talking about layer 4 countermeasures here. We're on the network stack. How do we defend against attacks against things like TCP and UDP? Well, one really simple first step is just disabling any unused ports. And not only that, but blocking any unnecessary protocols. ICMP is a perfect example. Do you really want to allow ping requests? You'll find that many services actually block the ability to ping them. They're simply disallowing a protocol which is not necessary. And this is really a fundamental tenet of information security. All of the things you don't need get turned off or disabled. And that goes for ports and protocols too. Now this is a very proactive measure. This is something you can go away and do well in advance of an attack. But when you do get to the point where an attack is in place and you need to start minimizing the damage it's causing, now we start to look at things like filtering ingress traffic. This is not necessarily particularly useful when you have legitimate traffic coming through, but ingress filtering will do things like block based on reputation. So for example, if there are a large number of TCP SYN requests all originating from the same IP, and doing so at volumes which is just simply not consistent with legitimate traffic, that would be an easy behavior to start to talk about blocking. Now along with blocking, we often see malicious traffic being black holed or tar pitted. And these are terms that both imply that incoming traffic is going to be sent off to somewhere else and no response is going to be sent back out. It's just going to be routed into a pit where it all disappears and nothing useful happens to it. Certainly the objective is to keep it away from that origin server. So if the target is a web application server, don't let it hit the web app server. Use that network appliance sitting in front on that layer 4 and route the malicious traffic off to somewhere else. And then, as I just said, it simply disappears. It's gone. Now you could always route that traffic off to another network segment and analyze it there. So there may actually be quite a bit of value in looking at what that malicious traffic was. Where did it come from? What were they trying to do? How can we use that to better prepare our defenses for if it happens again? So it doesn't have to entirely disappear. You could actually send it off and do something useful. The main point is, though, it's not going to go back and hit that origin. The challenge with all of this, though, is it's still a question of degrees. And if the attack is large enough, all of this filtering or black holing is simply not going to work because the network appliances will be overwhelmed. They simply will not be able to handle the volume of traffic. Now, this is one of the reasons why this is something that happens in addition to absorbing the attack. Have as much capacity as possible and then do your best to route malicious traffic away from the target it's attempting to hit. But capacity is always going to be a challenge. You've got to have enough of it. There is another really neat approach that's become very, very popular with DDoS mitigation that will help you absorb those attacks and reduce the risk of taking the entire system down. Let me show you what I mean. Anycast is a network addressing and routing methodology. And the idea of Anycast is that you can stand up a single IP address and then, depending on where the traffic originates from, route it to the nearest possible node. So as far as the external party is concerned, it's the same IP address regardless of where you are in the world, but all of the traffic gets routed to different locations, inevitably to the topologically nearest node, because that's what you want in terms of performance. Let me show you what I mean by that. Let's imagine we have a website, and then we have all of these Anycast nodes that are distributed around it. So each one of these Anycast nodes exists somewhere else in the world, different points of presence. As far as the external party is concerned, the website has the same IP address, but traffic from, say, the US is going to be routed through one Anycast node, whilst traffic from Australia is going to be routed through a different Anycast node. What that then means is if we get malicious traffic originating from one location and then targeting that one Anycast node, defenses can be implemented at that point to stop that traffic from going all the way through to the origin. So let's say we're talking about the Western European node. If attacks are being mounted from that location, the Anycast node in that region will receive the requests and they can implement the sorts of defenses we just looked at. Rejecting requests, black holing them, doing whatever they need to do to defend their node. But as I said in the previous slide, it's still possible for a DOS attack to overwhelm the infrastructure. But if it does, it's only going to overwhelm that one Anycast node. The other nodes are okay, they're still operating, they're not being targeted. So yes, we're losing traffic, but we're losing 1 out of 4 nodes. Now it may well be that it's a distributed denial of service attack, where we've got malicious traffic originating from all over the world. But even then, now that traffic is being spread over multiple nodes. So rather than having one node where all traffic has to pass through, the load gets distributed. So for argument's sake, if it is a 400 gigabit attack, and it's fairly evenly distributed across the world, each one of those nodes is only going to see 100 gigabit. We're not going to see any one node getting hit with all 400 gigabits. Now, of course, you've still got to implement defenses at those Anycast nodes because you don't want the whole 400 gigabits going through to the website. But because each one only has to deal with a quarter of the total DOS attack, they have the ability to filter that traffic out and try and reduce the load on that origin website behind the nodes. So having this model sort of scatters or dilutes the attack across these various nodes. And beyond just protecting against DOS attacks, by putting nodes in different geographically close locations to the traffic, there's other advantages as well. So things like edge caches, being able to serve content much closer to the user actually requesting it. This is the way Cloudflare implements their DDoS mitigations and also does a whole bunch of neat performance optimization things. We'll take a closer look at Cloudflare towards the end of this module. So that's a few different ways of approaching defenses at that network level. Let's now move on and take a look at how we'd handle it at the application level.